I talk about proofs of irrationality for square roots. Okay, so square root of 2 being irrational. Well, we can prove this by contradiction. So what that means is that if we set square root of 2 and we assume that it's a rational number, if we can prove that the logic in there is wrong, then we can prove that square root of 2 is irrational, because it's either rational or it's not. There's no in between. So if it's rational, then square root of 2 can be expressed as two numbers which are co-prime, basically meaning that this fraction, the numbers here, are as simple as they can be. They're already the lowest they can be. Alright, so following that logic, p squared over q squared, right, that should be equal to 2, because that's the fraction square to the power of 2. To the power of 2, you get 2. Okay, and then what you find, you shift this over here, p squared equals to 2q squared. Now let's think about what this means here. Well, using something called Euclid's lemma, which I have another video on, we can infer that p is divisible by 2. And the full explanation is in that other video. But basically, you know that p is divisible by 2 because it's made of 2 parts of q. Okay, so we know this. P is divisible by 2. So let's just set 2k, where k is any constant. Okay, 2k is equal to p. So then we get 4k squared, because it's p squared, equals to 2q squared. So we're basically just substituting into here, right? And we know we can set this as 2k equals to p because p is divisible by 2. So this k will still be an integer. Okay, so let's just simplify here. And once again, using that same logic with Euclid's lemma, we find that q is divisible by 2. Now hang on a minute. If they're supposed to be co-prime, meaning that this is already as simplified as it can be, and we found that it can be further simplified, then we just found a hole in the logic which proves that square root of 2 is irrational, because it can't possibly be rational. And this proof applies to quite a few square roots, but not all, because obviously you have perfect squares like square root of 4, and that's just equal to 2. But if you watch my video on Euclid's lemma and try and apply it to here, think about in what case, what square root of x, where this proof doesn't work, but we know that it's irrational. Post your answer in the comments.